Logarithmic function graphs. A logarithmic function is a function that has the variable in the argument of a logarithm. The simplest logarithmic function, we have the following shown on screen. For more advanced forms of logarithmic functions, we have the following shown on screen. The graph of a logarithmic function equation shows the line that includes all points that make the equation true. For example, we have the graph of the function y, x equals log 3x shown in the figure. We have the following shown on screen. The graph of a logarithmic function is a curve that extends to infinity on three sides but has some limitations on the other, depending on the value of the base and the sign of the exponent. For example, the above graph is unlimited in both vertical directions and on the right, but it is limited on the left. X cannot be 0 or negative. The best method to plot the graph of an exponential or logarithmic function is to find as many points of the graph as possible. If the formula of the function is known, we can provide some arbitrary values to the independent variable x and then calculate the corresponding y values. We have four types of numbers, coefficients or constants, that affect the shape and orientation of a logarithmic function graph. Thus, if we express the general form of a logarithmic equation, we have the following shown on screen. We have the following shown on screen. Then, the numbers involved are a, b, m and n, where their values and signs determine the orientation and dimensions of the graph, as in the exponential functions. For example, the graph of the logarithmic function, we have the following shown on screen. Is the vertically inverted version of y, x equals log 3x, as shown in the figure. We have the following shown on screen. We can find the values of the coefficients involved in the logarithmic function y, x equals m over n log a, x by solving the simplest form of the logarithmic obtained when substituting the coordinates of one known point of the graph. This allows us to find two unknowns at once, the base a and the coefficient m over n preceding the logarithm. Then, if necessary, we can attempt to find the values of m and n separately, given that they are whole numbers and the number of possible combinations is therefore limited. Let's consider for example the following logarithmic function graph. We have the following shown on screen. From the figure, we can identify two clear points on the graph, 3, 2, and 9, 4. Therefore, substituting one of them, for example the first, in the standard form of the logarithmic function, we have the following shown on screen. We have the following shown on screen. We write this value as a fractional power. In this way, we obtain for the base of the logarithmic function we have the following shown on screen. Therefore, we write the logarithmic function shown by the graph, we have the following shown on screen. However, this is not the standard form of writing a logarithmic function. Given the property of logarithm, we have the following shown on screen. We have the following shown on screen. And finally we have the following shown on screen. If you wish, you can also write this logarithm as we have the following shown on screen. From the numbers, we can guess the values of m and n since m over n equals 2. Thus, the most common version of this function would require that m equals 2 and n equals 1, but other combinations are also possible. Example. What are the logarithmic functions that corresponds to the following graphs? We have the following shown on screen. Solution. First, let's search for any clear point on the graph. For example, point 5, 7 has distinct coordinates, so it is suitable to be considered. Thus, considering the standard form of a logarithmic equation, we have the following shown on screen. We obtain after substituting x equals 10 and y equals 10, we have the following shown on screen. Therefore, we obtain for the logarithmic function shown by the graph, we have the following shown on screen. Again, let's identify a clear point of the graph first. We can easily see that 3 minus 4 is a point of the graph. Thus, considering the standard form of a logarithmic equation, we have the following shown on screen. We obtain after substituting x equals 3 and y equals minus 4, we have the following shown on screen. Although the base of a logarithmic function is always taken as positive, we will close an eye here to a rule violation, as after the necessary transformations, the base will be positive at the end. Therefore, the function shown in the graph, we have the following shown on screen. Hence, for the ultimate form of this function, we have the following shown on screen. That is all for lesson 13.3.4. To continue this tutorial, please watch 13.3.5, Modeling Curves Using Logarithms. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.com.